So I'll get started on my talk. I'm dmarz. I do some R&D at Flashbots. The D for me in particular, these last 2 quarters stands mostly for distribution. And so this talk will be a lot about use cases of anonymous broadcast, just to like motivate some of the different protocol designs and trade-offs I think we'll hear about later. Um, yes, I won't go over this, but the channel still leaks. I think that's kind of one of the main. It's a bit of a like AI slap framing, but that's one of the core things here is like a bunch of people have built things that provide anonymity once you're inside of the service, whether it's inference or a variety of other things. But the channel that you're sending through can still leak lots of information. And so I'll go through some use cases there to understand how. And so these are things like IP timing, like volume of your messages and sizes, and much more. So yeah, going to be framing the use cases. So we're going to talk about Ethereum block building, and then agents, which has been some of my more recent work. And then there was a live demo, but I think that's getting slotted later. Cool. So block building is one of the main places where we started discussing anonymous broadcast at Flashbots. And so actually real quick, who knows what block building is on Ethereum? I feel like you kind of have like a mixed crowd. Yeah. Okay. Well, every 12 seconds, there is, 1 out of a million validators is picked to propose a block to the network. Often these validators are running on a sort of minimal set of hardware, and to actually build a very profitable block, there's often a million transactions waiting to get into a block. And so there's these specialized actors who look at those million transactions, try to build the best block, give it to a validator. And so one of the things we built at Flashbots is something called BuilderNet. And so BuilderNet is a like block building network where the idea is all of the block builders run inside of trusted execution environments. And this gives you privacy over your transaction submission, privacy over the block building process, as well as like a testability of it. So you can sort of audit that the code is correct, and it isn't trying to like sandwich you or screw you over. It's sort of running like a quote unquote fair auction, although I know the word fair triggers some. And so we built this network, we deployed it. It was building 30-40% of Ethereum blocks at one point. I think now it's like at 15% or something. But basically what happened, and this is like the main motivating reason for anonymous broadcast for us here, is anyone can run these nodes. And so specific traders in the network started to run some of these nodes. And then there was sort of the fear in the air from other traders that, hey, yes, just one trader is running this node, and sure, I'm sending it to a T and it's private. But actually, what the trader running this T could do is they can put something right in front of the T, and they can't inspect any of the traffic because it's using an attested communication protocol, but they can sort of see the IP, see some of the sizing. And if you're able to correlate, hey, all of these profitable trades are coming from these range of IPs, maybe do some other snooping around, try and bait your competitors to reveal their IP. Well, now you can actually like selectively censor them at the network level. And so this thing that we use TEs for to sort of fix censorship now has this like next set of attacks that we wanted to patch. Yeah, and so that's basically it for BuilderNet. That's kind of like the motivation there. The other thing too is we initially started using or if we're experimenting with things like Tor, but one of the requirements here is like extremely low latency. Some of these searchers or these traders want like sub 100 milliseconds request and response, which is obviously extremely hard in an MV protocol. The next thing I'll bring up is Railgun. So Railgun's a protocol on Ethereum. It's sort of like it's sort of like a ZK, like a Zcash on top of Ethereum. It's like a very simple way of looking at it.
Moosey Cash is not the best analogy for someone who doesn't know what Railgun is.
It's like a tornado cache. Whereas
it's a private transfer cryptographic system.
Okay, that's good. I figured everyone knew what Zcash is. I guess I don't know. Who knows what Zcash is? Okay. Who knows what Railgun is? Who's used Railgun?
It's hard.
Right. Who's downloaded the app and never said anything? Okay. Anyways, so yeah, it's people are I think like somewhat happy is that is like a privacy protocol on Ethereum. You can do anonymous transfers, assuming there's a lot of people in the pool. There's a couple people there. Obviously, it's not that great. But one of the cool things they do is you don't need to send a full transaction. You actually sign this little message that someone else takes and puts into a transaction. And so Railgun runs these little relayers, and you submit these little signed intents to them. They're the ones that actually put it into a transaction and end up putting it on chain. And so this is another spot where your IP can basically like leak some of your identity when using this protocol. And so that's another area that like people want to patch this identity hole. And then the funny thing is the relayer actually creates a transaction that submits it to BuilderNet. So we kind of have the initial problem again as well, except a little less adversarial. So yeah, roughly I think the goal is just like unlinkable transaction submission on Ethereum or any other blockchain really, but we're quite focused on the Ethereum use case. Yeah, that's the rough goal. And then some interesting MVP requirements, and this is just focusing on many people sending to block builders, not this like sort of Railgun use case because that has like way less users right now, is something like almost 1,000 bytes per signed transaction. The latency is something like 12 seconds, less than 12 seconds. People generally are like not super mad if they get in within the same 12 seconds on Ethereum actually. If we're talking about the trading use case, that can go as low as possible, 100 milliseconds, since that's what I'm focusing on, just like the average user here. Any trust servers, this is something I guess like Mark and Matej will talk about. And like we want to assume that like roughly 10,000 clients are able to send to this kind of like parameter per every 10 seconds. Okay, cool. So I'll go through like agents now, some use cases there where it's relevant and some of the requirements, and that'll be it. So yeah, assume that now like some of the people sending these transactions are agents, these fancy pieces of software on our laptop. Also assume maybe those agents just aren't even using blockchains, they're using a variety of other services on the internet. And so now they're kind of like one of the main economic actors potentially in the next few years that we can look through. And we actually have a agentic nev.wtf event in SF to actually discuss this specifically. That's a live website if you want to go register. So very simple mental model for an agent, just to get on the same page, is like you have inference, that's the core place where there's thinking, you have some memory, it's super fancy, maybe it's super simple, and then you've got a bunch of tool calls. You've got code execution, you've got the ability to like maybe pay with links to a wallet and all these things. And then you've got web search, which is one of the main things I'll talk about here, as well as inference. So for inference, and this is sort of similar to the BuilderNet case, we have sort of solved like private inference. I think actually Tinfoil does private inference. You probably have maybe other people here. But you put the LLM in a T. It's kind of simple. There's also much more advanced versions, but I don't think we're like anywhere close to FHE LLMs yet. But yeah, that's like roughly it. You put it in there, and then you have this kind of same exact problem where, okay, you could actually now start de-anonymizing the person based on like the traffic coming into the T inference provider. So it's very similar to the BuilderNet case. There's, I think the interesting thing to call out is there's like 2 inference workloads, and the second one's way harder. One is just like a one-time query. So whatever, you're just asking it to, giving it your health data and asking it to diagnose you or whatever. And then there's agentic coding sessions. And so this is, tons and tons of calls, often very synchronous and very easily to link to each other. Yeah, the context window basically like de-anonymizes you. I don't know if anyone's actually like worked on how easy it is to tell, but you can think of it that, you do one query and then the results of it, you take some subset of that and put it in your context window. And so you always know that the next message will like grow somewhat proportionally to the response to the last thing, which makes you a lot easier to link over sessions. So yeah, I think we want unlinkable queries, but we also want unlinkable sessions. I think unlinkable sessions are extremely hard, and I'm not actually sure how we go about that. I think for unlinkable queries, we can use a lot of the anonymous broadcast tech we have today in conjunction with a lot of the inference providers, and we should get free card. And so I think, yeah, something interesting is like for an MVP requirements of this, like 8 kilobytes per prompt, maybe thousands of kilobytes like streamed back to you, or hundreds. Latency is probably seconds. And there was an interesting Twitter discussion of whether agents should be like network bound or like inference bound. So we can't get too high, but I think if your response maybe takes twice as long, you might not notice. And then yeah, probably hundreds of calls per coding session is the type of workloads a single client will be doing. And then I'll just talk about web search really quick. So I don't know about you guys, but I focused in on web search because that's when I sort of analyze my agents, one of the main things they do is web search, on top of like doing inference and code execution. And so this is again also maybe a similar type of scenario where we could put the entire index in a TE and just like return you responses. Some of the indexes are like extremely big. There's also this pretty cool paper, Tiptoe, which has a like lattice encryption kind of PIR based search engine, which is like, I think they're like, it's for to search over 360 million documents, it's something like 2 seconds. And so it's actually like pretty feasible. I think of course Google has 100 trillion pages indexed. But yeah, again, this is kind of the same exact thing. As mentioned before, where, assume we have those, or assume even you're actually just okay with revealing your search query. Maybe you're just like searching some papers on archive or whatever. It's like you're actually just cool with giving that to Google. But you still want to maybe hide your agent's identity. That's where you would input one of these anonymous broadcast protocols. And then another thing that I wanted to look at is basically, so I think we have Tor, which is, I'll explain this in a second also, this slide. But so Tor, you have like, you hop to one node, you hop to another, it's sort of like path based. The DC nets and mixed nets are much more round based. So, like if you send your message to the node halfway through a round, it needs to wait till the next round, right, to include you. And so one of the questions we started asking from like just like a user research perspective is like, can agents like easily integrate with this? You would think the path-based routing is like much better. Or actually, this doesn't answer which one's better, but you would think that would be much more amenable for an agent to just be able to fire out whenever it wants. But actually, when we started doing benchmarks over a bunch of different agent deep research like sessions, so asking it to do a variety of tasks and recording all its tool calls and all these things, most of the, or at least in this case, Claude Code, does all of its web search in parallel, and normally these like big batches. So these teal things are like web search tool calls. And so you can see that it'll do it in like 6 in a row, maybe batch 2 of these together. And then it's got a decent amount of time where it's actually like interpreting the results. And so this basically just says, okay, probably round-based protocols are feasible because an agent can sort of just schedule these things ahead of time. They're not less humans.
Why the architecture?
Yeah, it's I don't know why I guess they have their own like custom book archive search. Yeah, there's probably also a burned books search tool in just yeah, so I want to do this actually for like all of the agent frameworks and stuff just to understand. And yeah, I won't go into this. A bunch of people have defined this, but it's kind of, the goal here is like an unlinkable query. I think a realistic thing for the near term, just like next few months, is totally using T inference like tinfoil plus having some like basic anonymous broadcast, and then, not trying to have your entire coding session private. I think that's like quite hard right now, but maybe in like a year or two. Okay. Yeah, that's it. I'll just kind of skip that. Yeah, and that's the end. Yeah, and hopefully that's helpful because I think we've been talking with lots of anonymous broadcast designers and researchers, and the thing is always like, what are the use cases? You know, we have all these protocols. How do we filter it down? So it's kind of the goal.
But wait, question.
Oh, okay.
Tinfoil. Yeah. I'm curious if you guys, if the numbers for inference requirements or like just generally also people's preferences in terms of latency, these kind of things, that reflect that could be. Yeah. What did you guys see?
I think people are very, very like speed sensitive. And like I was thinking about yeah, this problem of how do you like maybe batch queries together, or do like provide more anonymity and stuff. But we get complaints from people being like, your web app uses too much battery power, and so or like your web app uses too much, like the network is you're using too much my 3G, right? Or 4G. And so I think like it's interesting how you could like balance, maybe some of the things you have to do for anonymity, like having more network headings and stuff like that, with like real world people's requirements, just like this thing needs to be as fast as possible.
I think it also depends on the use space. It's not like HN3 coding, like you're not gonna be as like sensitive. So like what you said about like it being okay to have like a round base print block like that, that makes sense. Or like something like trap.
Yeah, I think that's really true. And then maybe another trend to even connect it to is like, I think people are talking with a single agent less. They're talking with like the agent that orchestrates all the sub agents, and so I think this is even more true in that world because you're sending less messages.
Yeah, I think like I was thinking about the web search batching, right? Like if you have multiple sub agents, like all needing to do their web searches, but you could have like one working while the other one is paused and doing like waiting for the next web search round and stuff like that. So there's a lot of interesting ways that pattern can be mapped to some anonymous protocol.
Yeah, that's why I'm quite bullish. Agents being like a leverage point for privacy, because humans are like, whatever. I do the query and I'm like,
yeah,
pissed off until it comes back, and then I do the next. But agents don't have this.
I think there's like two subtle things. There's like also who's doing the actual like mixing, like maybe it's some back end in a data center, but you're still mixing all of your users' queries, potentially even with other private LLM providers' queries. But I also had two questions. One is like, do you think if there was a privacy toggle and people had to wait a little bit longer, that they would be okay with that? And the second is, if it were equally fast, do you think people would pay for more privacy, or do they kind of have some floor there? How does that?
I said that's our goal.
Yeah.
I mean, it's
Okay.
instance group also.
Okay. Yeah. That's
We do pay more for tinfoil, even though it's slower.
Yeah.
Just because we don't have enough GPUs to make it fast. So yeah.
So you feel that's validated?
We make our inference more expensive so that we validate that essentially, and that you get so much usage that like we can't sustain it with our demand. So with our like compute. So yeah.
That's what I hear from Palo too. Is like they're like, we can't get enough hardware. And
Exactly.
Wait, this probably only works for a single query thing, right? Like if you're doing multiple queries and going back and forth, you are better off caching all the prompt and the code which is already there. Oh yeah. There's also some way to track, like backtrack all the messages and identify it's the same person.
yes, yeah, that's what you want to card.
Trevor, I'm curious. You have spent used to work at Signal or on Signal, and I spent a long time thinking about privacy and anonymity in the internet. Maybe like 2 years ago or 3 years ago, you wouldn't have seen agents in a presentation like this. And I think one of the most exciting things from what Dan has been looking at is it feels like there is a new opportunity to like squeeze anonymity or privacy into the internet. Do you feel like the conversation has significantly changed because of AI, or do you think the problems are sort of still the same that have been around for a while?
was like answering your ability to know things, or it's like you want to talk to AI, or it's really different? Or
I guess it changes I think Dan's point is sort of it changes the way that information flows, where a lot of our interaction with the outside world is about intermediated by these AI agents, as opposed to us like directly making queries on Google or directly trying to send messages or making payments.
Yeah, like maybe in my day to day, my agent handles grabbing my groceries, calling the Uber, these 10 other things, which normally, if I'm about to hit that button and I have to wait longer, I'm going to be annoyed. But now, if my agent's kind of scheduling these things for me ahead of time, it can sort of take that wait and see hit his argument.
yeah, I think I hadn't thought about that. Yeah, maybe it makes latency or things more mobile faster. You mean that assuming the aliens doing these things for us? Yeah. I mean, some ideas that people have that can be that's happening about origins kind of also asserting as your like private guardian kind of locally running, kind of doing modern your privacy gadgets and there's something like that, but it's not. So reality is what they are. Right? Maybe.
Sweet.
Cool.
I have a questions. So this is regarding I think mentioned at some point that it's round based, correct? So which means that the several users have to sort of send requests within a certain stipulated amount of time, right? Like could you expand more on
The next talk
like where they
expands.
have to synchronize sending
I think they're just calling for Mark to step up. That's what the whole next talk is about. So.
Yeah,
Oh.
Mark, do you want to come up?
Okay.
But there's
I've got no. You can start, but I've got one more thing to hijack.
go.
Okay, so I wasn't supposed to do a demo, but also I think are you guys from Open Anonymity?
Yes.
Okay, we've been chatting on Signal. You want to give a? Sorry, I'll make this. This will be. You want to give like a explainer of the Open Anonymity project real quick?
Yeah, sure. Hi everyone. My name is Eric. I was the CSQC at UWish, and I started to work on Open Anonymity project like last year. The reason is that I was working on anti-censorship and anti-censorship problem, basically like helping people in China invent bypass their firewall. And then we realized that AI is here, so that we should help people access frontier models securely. That's the reason that we started the OA project. And what we basically do is like we realize that people don't really like open weight models back then, like a year ago, but now open weight model is getting better. So we are trying to think about ways to access frontier models, basic model. And because frontier models are closed, so there's just like two ways you can make your prompt secure. Basically, either your prompt goes to the model or the model arrives at your device, basically. So we can only do the first part. So we have to have a bunch of like proxy accounts so that all users prompt is going to like get into a pool and mix and then like a tour and like distributing your traffics basically. And then we also try very hard to hide like the metadata because I think someone also bring that up. So we made a in-browser VPN so that your traffic sending to the servers will remove your IPs basically. And also the authentication part is a little bit hard where we've been using a blind signature so that the user can authenticate themselves to the server without letting us know that who is requesting the key, basically. So that's basically the back end of this OA chat project, and we also did something else above that. So basically some memory stuff. So people are starting to use AI more and more. Like you want to have memories basically, and that's why people stick with ChatGPT or Cloud. And our argument is that your queries should only have context relating to this query. So basically selectively disclosing information. And by doing this, as we're using like the tinfoil's model and the open weight model, looking at the chat history you have, and then distill the memory points out and store that in the web app, which is completely local. And then when you sending a new query, we'll have the TE model look into the query again, and also look into all the memory dot points in your in the web app and try to find the only related things, and then augment the query and send that to the function model, so that you get like kind of a trade-off where you have some memory but your prompt is still unthinkable. Yeah, so we call this kind of like a secretary model.
Cool. Yeah, and then one thing I'll show really quick is I basically grabbed their OA chat from GitHub, which you can insert a bunch of models. I just had it as a mock model right now. And I added into the network proxy FlashNet, which we described, Tor, and then this other project I did, which is actually a Tor onion service that takes a ZK proof of identity and uses a rate limiting nullifier, so you only get 5 requests per second. And so you can just do a little mock query. It just returns some random value. But you can see 3-hop Tor is like 515 milliseconds. This one takes onion services. Sometimes they take a while to like get hot. And then FlashNet's 5.3, and this is perfect person.
Wheels those come up.